Hi everyone, welcome back to Coder Jets at Joy. You know that feeling when you're about to unlock a new achievement, like you're on the verge of leveling up your skills? We're gearing you up for success in your Python interviews. If you're preparing for a Python interview, you're in the right place. We're diving deep into essential Python interview questions. Think of this as your cheat sheet, your guide to acing those technical rounds. All right, let's start with the basics. What exactly are we talking about when we say Python? Imagine a programming language that's so versatile, it's like the Swiss Army knife of coding. That's Python. It's a high-level language, which means it's designed to be human-readable and easy to understand. Python is incredibly powerful. It's used for everything from web development and data analysis to machine learning and artificial intelligence. And the best part, it's known for its readability and simplicity. Think of it as writing code that your future self will actually thank you for. What makes Python so cool? It's incredibly easy to read and write. Python's syntax is close to natural English. It's like reading a well-written blog post. Python is interpreted, no need to compile. Write and execute code line by line. Python is dynamically typed, no need to declare variable types. Python figures it out, saving time and reducing code. Now let's talk data types. Python comes loaded with built-in data types that are like the building blocks of your code. First up, we've got the numeric types, and these are your go-to for handling numbers, whether they're whole numbers, decimals, or even complex numbers. Then we have sequence types, which are used to store collections of items. And lists are like your trusty toolbox. You can change their contents whenever you need. Tuples, on the other hand, are like sealed containers. Once you put something in, it stays there. Let's talk about PEP8. PEP8 sounds like a new type of breakfast cereal, but it's way more important. PEP8 is the style guide for Python. It tells you how to format your code so it's clean and readable. PEP8 helps you write code that others can understand. Now let's dive into the world of memory management in Python. You might be wondering, do I need to be a memory ninja to write good Python code? The answer is no, and here's why. Python has this amazing feature called automatic garbage collection. Think of garbage collection as your automated cleanup crew. It keeps track of all the objects in your code and figures out which ones are no longer being used. Once an object is no longer needed, the garbage collector swoops in and frees up that memory. This automatic memory management is a huge advantage of using Python. Let's break down the difference between two fundamental data structures in Python: lists and tuples. Think of lists as your dynamic, ever-changing to-do list. You can add items, remove items, and modify existing items. They're mutable, meaning their contents can be changed after creation. Tuples, on the other hand, are like the permanent records of your code, set in stone and unchanging. Once you create a tuple, its elements are fixed. You can't add, remove, or modify elements. They're immutable, meaning their contents cannot be changed after creation. Let's talk about decorators, a powerful feature in Python that can level up your coding game. Imagine you have a function and you want to add some extra functionality to it without directly modifying the function's code. That's where decorators come in. A decorator is like a wrapper that you put around a function. It takes the original function as input, adds some extra source to it, and then returns the modified function. Decorators are incredibly useful for tasks like logging, access control, and timing functions. They promote code reusability and keep your code clean and organized. Let's unravel the mystery behind two special methods in Python. And Djitsu, on the other hand, is like the interior designer who comes in after the building is constructed. It's responsible for initializing the attributes of the newly created object. Let's talk about two special syntaxes in Python that can make your functions super flexible. Imagine you're writing a function, but you don't know in advance how many arguments the user will pass in. That's where comes in, allows you to pass a variable number of non-keyword arguments to your function. Now, what if you want to pass a variable number of keyword arguments? That's where steps in, allows you to pass a variable number of keyword arguments to your function. Let's dive into the world of copying objects in Python. You might be thinking, why do I need to copy an object? Can't I just create a new one? Well, it's a bit more nuanced than that. When you copy an object, you're creating a duplicate of it, but there are two ways to copy: shallow copy and deep copy. Think of a shallow copy as creating a clone of a person, but only copying their clothes and hairstyle. The clone might look like the original, but they're still two separate individuals. Now, imagine a deep copy as creating a clone that's an exact replica. Same clothes, same hairstyle, same memories, everything. Let's talk about generators in Python, a powerful tool for sequences of data. Imagine you have a massive list of numbers to process. A loop could consume a lot of memory if the list is huge. That's where generators come in. Generators produce values one at a time, only when needed. They are memory efficient and improve performance with large data sets. Let's talk about the global interpreter lock, or GIL, in Python. Now, the GL can be a bit of a controversial topic, but understanding it is crucial, especially if you're working with threads. In essence, the GIL is like a single lane bridge that only allows one thread to cross at a time. This means that even if you have multiple threads in your Python program, only one thread can execute Python bytecode at any given moment. This can be a bottleneck for CPU-bound tasks, as it limits the potential for true parallelism. However, it's important to note that the GIL doesn't completely prevent multi-threading in Python. Let's break down the difference between two common method decorators in Python, and these decorators are used to define methods within a class, but they have distinct purposes. Think of as a regular function that just happens to reside within a class. It doesn't take the instance of the class or the class itself as the first argument. It's like a standalone function that's grouped with the class for organizational purposes. On the other hand, is more tightly coupled to the class. It takes as the first parameter, referring to the class itself. Let's talk about list comprehensions. A concise and elegant way to create lists in Python. Imagine you want to create a list of the squares of numbers from 1 to 10. You could write a for loop, append each square to a list and call it a day. But with list comprehensions, you can do this in a single readable line of code. Here's the magic. This single line of code does the same thing as a multi-line for loop. List comprehensions are not only concise, but also efficient. Let's talk about lambda functions, anonymous compact functions that can add a touch of elegance to your Python code. Imagine you need a small function, but you don't want to go through the hassle of defining it using the keyword. That's where lambda functions come in. You can define a lambda function using the keyword, followed by the arguments, a colon, and the expression to be evaluated. For example, just like that, you've created a function that adds two numbers without giving it a name. Let's write a Python function to check if a string is a palindrome. A palindrome reads the same backward as forward, like madam or race car. Compare the original string to its reverse. If they're the same, it's a palindrome. Def is palindrome. It says, return s equals sign sut. Try it out with different strings. Let's write a Python function to calculate the factorial of a number. The factorial of n is the product of all positive integers less than or equal to n. For example, 5 factorial is 5 times, 4 times, 3 times, 2 times 1. We can use recursion to calculate it. Here's the Python code. Def factorialum if n equals sign 0. Return 1 else return n asterisk factorial and then 1. This function recursively calculates the factorial. Let's write a Python function to merge two dictionaries. In Python 3.5 and above, we can merge dictionaries using the double asterisk operator. This operator unpacks the contents of a dictionary. Here's the Python code. Python def merge underscore dict, dict1, dict2, return dict2. This function provides a concise way to merge two dictionaries into a new dictionary, effectively combining their key value pairs. It's a handy tool for managing data in Python. Try merging different dictionaries to see how it works. You'll find it simplifies many coding tasks. It's a must-know for any Python developer. So, all right, we've covered a ton of ground today. We went from the fundamentals of what Python is all the way to writing functions for palindromes, factorials, and even merging dictionaries. You've leveled up your Python knowledge and you're well on your way to acing those technical interviews. Remember, practice makes perfect. The more you work with these concepts, the more comfortable you'll become. So, keep that coding momentum going, and I'll catch you in the next